Good morning, everyone. In this class, already we know that we have learned about RNN, LSTM. That means these architectures are useful for sequential analysis, right? Sequential problem analysis. And now we are coming to the GRU. GRU is nothing but gated recurrent unit. So in one way or the other way, we can say that GRU is some advanced version of your LSTM networks. LSTM is what? LSTM is long short-term memory. So as we know that RNN is having, that is vanilla RNN. Vanilla RNN is conventional recurrent neural network. It is having the problem of vanishing gradient problem, short-term memory and exploding gradient problem, right? So why we have chosen the LSTM networks? LSTM networks we wanted to choose or we wanted to develop because to rectify the problem of RNN regarding the short-term memory, right? We have taken the example of Gajini movie, etc. So I hope you remember all those things. So coming to so in LSTM we have incorporated what? We have incorporated a short-term memory and a long-term memory, right? We have incorporated two memory cells. One is short-term memory for updating the consecutive words, right? But long-term memory, it is only for saving the important words. That is, if we wanted to, if I am taking the same example like samosa, if we have the knowledge of samosa, then only we can predict the cuisine as Indian. And at the same time, if we are going to say brother is having liking towards cheese and pasta, so then the brother's favorite cuisine is Italian. So when we can predict the Italian, if we have knowledge of cheese and pasta. So all these things, I am again repeating the same. So these things will be there if we have a long-term memory, right? So and when to when to add the memory of cheese and pasta, and we wanted to remove the samosa, all these things we have seen in the last class. Now coming back to GRU has developed in 2014, okay, by Cho et al. In their paper. So GRU is also basically used for long-term sequences like LSTM, but it's an improvised version of LSTM. So what is the improvised thing? See, to keep the information from long ago without washing it through time or remove information that is irrelevant to the prediction that we need to wash out, right? To explain the mathematics behind the process of GRU, we should go for the architecture, okay? So this is the basic difference between, see, many of the things that I have adapted from Code Basics. It's a YouTube channel. You can also refer the things for LSTM, GRU and RNN. Okay. So this is the basic difference between LSTM and GRU. In LSTM, we have two memories, which are the one is short-term memory and one is long-term memory. Short-term memory consists of H of t and long-term memory consists of C of t. That is nothing but H of t minus 1 is the previous memory in T1 state or T minus 1 time, and H of t is the current input or current hidden state, or we can say current memory state. Similarly, C of t minus 1 and C of t are the memory states. Which memory? Long-term memory states of t minus 1th sequence and t sequence, that is current. So this is LSTM. But in GRU, we have combined short-term memory and long-term memory into a single hidden state. So what happened? We have no C of t channel, or we don't have any C of t memory. Instead of that, we are having only H of t minus 1 and H of t, which contains both long and short-term memory. So this is the basic difference between LSTM and GRU. So in the last LSTM, we have seen input gate, output gate and a reset gate, right? Reset gate is for resetting the memory, long-term memory. Whether we need to keep samosa or when pasta and cheese comes, or we wanted to reset that if pasta and cheese comes. For that, a particular reset gate is also there. But here we have two gates like update gate and reset gate. Okay, update gate and reset gate. So what is update gate will do? How much of past memory we have to retain. Okay, and reset gate, how much of past memory we need to forget. So basically these two, I mean, hearing, if we are hearing this, we think that these two are similar, but no, these two are having different propaganda, right? Different aims. Update gate, how much of the memory, past memory we need to retain. When pasta is there, when cheese comes, we need to retain the memory of pasta and we need to include cheese, right? So that will happen in the update gate. But reset gate, what it will do, how much of the past memory we need to forget. That means when samosa is there in the long term memory and when pasta comes, we need to forget about the samosa and we need to add the, or we need to update, or we need to reset that gate with this pasta. So this is the basic thing. I mean, this is the aim of your update gate and reset gate. So you are having an X of t input, H of t previous memory. These two are going to update gate and reset gate, and output will be H of t. So after update gate and reset gate, what is the operation inside the reset gate? It's an again a, we are having a weighted sum. Okay, this plus means we are having a weighted sum. UR and WR as what? They are the weights. They are the weights of reset gate. Along with X of t, we are having a weight of WR, and along with H of t minus 1, we are having a weight of UR. Then we are going to go for a weighted sum here with an activation function of sigmoid. Okay, and that sigmoid function ka output is what? R of t. R of t is the reset gate output of the current type. Okay, so reset gate mein kya hota hai? When pasta comes, according to the same example of LSTM. See, I am talking the same example, that then only you can relate your LSTM and GRU. Okay, so here when pasta comes, we need to reset, right? Reset the gate. We need to forget about samosa. So what is the equation will become? R of t equal to sigmoid activation function we need to apply on the weighted sum, on the weighted sum, that is WR, UR, X of t and previous hidden state, that is H of t minus 1. Okay. Now we have an update gate, right? In GRU we have two gates, update gate and reset gate. So in update gate, what happened in update gate? Again, it's a sigmoid function. This comes a weighted sum of X of t, H of t minus 1, and we will get a Z of t. See, I mean, I have an, I will pronounce this as Z, you can pronounce it as Z. There is no difference between Z or Z, okay? So the output is Z of t. So, but see, there is a difference, right? In the weights, there is a difference. In reset gate, we used the weights of WR and UR. Here in update gate, we are using WZ and UZ. Okay. So what will be the equation? So here what happened? When pasta comes, it was reset. It forgot about the samosa here, right? It forgot about samosa. But see here, when cheese comes, it has to update the gate. It doesn't needs to reset the gate. That is, we need to retain the memory of pasta. Along with pasta, we need to add the memory of cheese, right? Then only we can predict the cuisine is Italian. So now the equation will be again what? The sigmoid activation function we need to apply on the weighted sum of X of t and H of t minus 1. Weights are WZ plus UZ. Okay, fine. Now this is the overall architecture. Okay, update gate, reset gate, we have X of t, H of t minus 1, and here R of t, Z of t are the two outputs of reset gate and update gate. Now this function, this multiplicative function is nothing but a Hadamard matrix. What is Hadamard matrix? See, if you want to look on Hadamard matrix, I will check in here. Hadamard matrix. It's nothing but element wise multiplication. See, This is element wise multiplication. H1, H2 and H4 we have to, oh sorry. See, this is your Hadamard operation, that is 2 into 3, element wise operation, 2 into 3, 3 into 1 and 1 into 4. Here 0 into 7, 8 into 9, minus 2 into 5. That is x11 into x21, x12 into x22, x12 into x22. In that way it will be, that is simply a dot product. Okay. So that comes here, the Hadamard element wise multiplication comes here. Now we are having a minus 1. Okay, minus 1 is for reset. Here we have 1 minus, that is, this is nothing but inverse multiplicative operation. Z of t comes here, inverse multiplication we are going to have 1 minus z. Then here tan h function we need to go for a activation function in the outside, and we are again going for the weighted sum. So here we will got h of t and this output is y of t. If we want to output our h of t, then we can take it here intermediate result. Otherwise we can omit this y of t. Okay. So then here comes the difference between LSTM and GRU. In LSTM we have 3 gates, input output for that. In GRU we have only 2 gates, reset and update gate. Then which is more accurate on longer sequence? Of course it is LSTM, but it is less efficient. But in GRU computation is higher. Okay, more efficient, but computation wise it is taking much time. Okay, and GRU is itself is the more popular. And when did this both invented? In 1995 and 1997. Okay, and in 2014 GRU came. So this is basically your architecture, another version of architecture. So these are the equations that previously we have seen. So the same thing, you can go for the previous equations. Then we have an update gate, reset gate, candidate cell, final state. All this information I will give you. So you can check the Moodle for your content. Okay, PPT. Thank you.